Hello children, welcome to your chemistry class. In this video we are going to discuss about your another properties of periodic table, that is electronegativity. So in the last video we discussed about the electroaffinity, and today we will discuss about the electronegativity. So let's start. So what is electronegativity? Electronegativity is a tendency of a bonded atom to pull a set pair of electrons towards itself. Okay, so what does that mean? Suppose A and B, these two atoms are bonded by one bond. Okay, this is your bond. So in one bond, how many electrons will be there? So remember, there will be your 2 electrons. Okay, so that 2 electrons, they are said to each other. Okay, so if A or B, if any one that pulls the said electron towards itself, then that is called your electronegativity. Suppose your B pulls towards itself. Okay, B pulls towards itself, then this is your electronegativity. Okay, and electronegativity is only a measure of the tendency of an atom to pull the said pair of electrons in a bond. It is not accurate. Okay, it is only a relative value, you can say. Okay, so electronegativity is a relational property. Then another important thing, electronegativity is made on the Pauling scale. Remember, your electronegativity is measured on the Pauling scale, and it has the value from 0 to 4. Okay, then for example, the electronegativity of hydrogen atom is 2.1. So if any other element or any other atom, if that is bonded with your hydrogen atom, that should have the lower electronegativity value. After that only we can show the electronegativity of hydrogen atom. Okay, if any other element, suppose A bonded with your hydrogen atom, this A atom should have the lower electronegativity value. After that only we can show that your hydrogen has the higher electronegativity value. If it is higher, then there will be not. Okay, this means the hydrogen atom tends to pull the electron pair more than the other element in the bond if the other element has lower electronegativity. So if this atom, okay, it has the higher electronegativity, that means it shows that this A pulls down the said electron towards itself. If we are going to show that hydrogen have the higher, or hydrogen pulls the said electron towards itself, then your hydrogen should be the higher electronegativity. Understood, children? Okay, then variation of electronegativity. So in the previous properties also, it depends upon the two properties, that is your atomic radius and nuclear charge. So larger the atom, more the shielding of the nucleus from the said pair of electrons in a bond. Lesser the tendency to attract the electron pair and lesser the electronegativity. So what does that mean? So before also we have discussed that in a larger atom, okay, in a larger atom the nucleus will be in the middle, and there will be the nucleus will not come contact with the electrons present in the outermost cell, because inside there are so many electrons present in the other cells. Okay, so there will be the shielding effect. That means the electrons present inside, they repel the outer electrons from the nucleus. Okay, that's why lesser the tendency to attract the electron pair. Okay, so if the electrons present inside the or nearer to the nucleus, okay, or it is nearer to the nucleus, the electrons, they repel these electrons towards outside. Okay, that means these electrons, they repel these electrons from the nucleus. Okay, then there will be the lesser tendency to attract these electron pairs towards your electrons. I think you can't see clearly. Look again. Suppose this is your one atom structure. Here is the nucleus. Here are some other orbitals where the electrons are there. Here are the outermost orbital where the electrons are there. So as the electrons are present in these orbitals, these electrons, okay, which are present outermost orbitals, they can't come inside or they can't come nearer to this nucleus. Okay, so there is no chance, or you can say there is a lesser chance for the contact of this outermost electrons to the nucleus. Okay, so this way there will be the lesser electronegativity. Understood? That means these electrons cannot come closer to the nucleus, because the definition of electronegativity is, it is the tendency of an atom in a molecule to attract the set pair of electrons. If there will be this much distance, how they can attract the electrons towards nucleus? Okay, so we can say that smaller the atoms, okay, smaller the atoms, they have higher electronegative values. Higher electronegative values means what? There will be more chance to attract the electrons towards itself. Okay, so remember, larger the atom, lesser the electronegativity. Smaller the atom, higher the electronegativity values will be there. Okay, then nuclear charge. Larger the atom, more the nuclear charge, more the tendency to attract the pair of electrons in a bond. So you already know that across a period, okay, your atomic size, your across a period atomic size your decreases, okay, and nuclear charge increases. And down a group, okay, down a group your atomic size increases because the number of cells increases. So like that, in the electronegativity, if the atom is larger, then your nuclear charge will be more. That means that there will be the tendency to attract the pair of electrons in a bond. Okay, then we will see the variation of electronegativity in a period. Okay, we will see here the variation of electronegativity in period. Okay, electronegativity increases, reaching the maximum value with the halogen element. Here you can see your chlorine is the halogen element, and here it increases from left to right, that is your across a period from sodium to your till chlorine, where your chlorine is the highest electronegativity value. Okay, inert gas element have zero electronegativity as they don't generally participate in bond formation with other elements. This one we have already discussed in the previous video, why the inert gas elements do not participate in the bond formation. Because in case of the other element, that is the covalent radius, but in case of your inert gas element, that is your van der Waals radius. Okay, why your inert gas elements do not participate, we have already discussed in the previous video. You can see there. So let's see the example. The elements of third period show graded variation as given below. So here you can see this is the across a period, that is about the third period. Here you can see the sodium has the least electronegativity value and chlorine has the highest electronegativity value. So what we observe in the across a period, electronegativity increases steadily across the period, first thing. Then chlorine is the highest electronegativity value in the third period, and sodium is the least electronegativity value there. Then similar variation is found to be true in other period also. So we show the your third period variation, and that will same as the other periods also. Okay, then what is the reason? As we move across a period, the metallic character decreases and non-metallic character increases. So about the metallic character and non-metallic character still we have not read. So about this region, when we'll read about the metallic and non-metallic character, at the time we will discuss. Okay, then we will see variation of electronegativity in a group. So this is your first group. So here you can see your electronegativity decreases. Okay, so first one your hydrogen, then your francium. So here you can say the hydrogen has the maximum electronegativity value, whereas your francium has the lesser or least electronegativity value. So why the electronegativity decreases here? Because as we move down a group, there is an increase in the number of cells. The shared pair of electrons in the bond is sealed from the nucleus and repelled by the inner electrons. So your electronegativity decreases. So as I told you, down a group, okay, your atomic size decreases because the number of cells remains same, but the number of valence electrons here increases. Okay, and if the number of electrons increases, there will be the shielding effect between the nucleus and the other electrons, and the outer valence electrons are repelled by the inner electrons. So your electronegativity decreases. Okay, I think you have understood the electronegativity property also. In the next period we will discuss about the metallic and non-metallic character, and we will discuss another important thing, that how you can remember all these properties in one table. Okay, thank you.